Hi everyone, welcome to my channel, Maths Made Easy with Terry in 10 minutes. So today we'll be talking about poles of a rational function. Please make sure you review my previous videos, and if you've not liked, subscribe, share. I don't know what you're waiting for. Don't forget to click on the notification bell so that when I post new videos, you'll be the first person to know. All right, so when we talk about the holes, when we say the holes of a rational function, basically we're talking about these are points that seems that they are present on the graph of a rational function, but they're actually not present. So that means you could have normally, maybe if this was your rational function graph, don't worry, I'm going to talk about it soon. Okay, so if you had this rational function graph, now it looks as if that this is the graph, but actually the graph was meant to look like this. Like basically what I'm trying to say is that there was a hole in the graph. So we had a graph like this, right? So, but actually what was there is that there was a hole in the graph at this point here. So that means we can draw the graph like this, like that. So that means you just basically, these are points that seems to be present, but they're actually not present. So that's what we call the holes. So I'm going to write it. So holes. So when we say the holes of a rational function, all right, the holes of a rational function. The holes of a rational function are points, all right, that seems. So the key word is seems. It looks like that they are present. Okay, so it looks like they are present on a graph. So it looks like they are present on the graph of a rational function. It looks like they are present on the graph of a rational function, but they are actually so it looks as if they are present, but actually they are actually not. So these are when we talk about the holes of a rational function, these are points that it seems to be present, but they are not present on the graph. Now, one thing I want you to keep in mind is that not all rational functions have holes, okay? So not all rational functions have holes. Okay? So not all rational functions have holes. So you need to keep in mind that not all rational functions have holes. All right? So some rational functions does not, while some do. All right. So it's important as well to when we get to graphing, it's important for you to check whether a rational function have hole before you start sketching the graph. All right. So how do you find this? All right. As usual, I will give you the steps. So we have 8 steps or rules for this. Okay. So you can call it steps, you can call it rules on how to find this. So the first thing that you have to do is that you have to write, all right, write the rational function in standard form. So you have to make sure you've written the rational function in standard form. So I've talked about this in the previous video. So I told you the standard form of this is f of x bx over qx plus d, or you can say it is a over what? Bx plus c plus d, all right? So there are different ways of writing this. So, and I also told you that for this to be a rational function, the qx must not be equal to 0, and the bx plus c must not be equal to 0. And I told you that for it to be a rational function, you have to be a ratio of 2 polynomials, but the numerator can also be a constant, all right? So when you've written this in rational function, in the standard form, the next thing you have to do then is to then factorize the numerator of the function. So the next thing you do is that you factorize the numerator of the function. Okay, you factorize the numerator. So I'm talking about the px here, all right? So what I'm referring to the numerator is the px. Now, in this case, you have a constant, you don't really do anything, all right? But when you have a polynomial of any type of polynomial, a quadratic, a cubic, any form, now you have to factorize it. And I've shown you how to factorize cubic, and I've shown you how to factorize polynomial. So, all right, and quadratic equation as well. I showed you how to factorize quadratic, and I showed you how to factorize cubic. So please go to the previous video. I've talked about each and every one of them. Then when you're done factorizing the numerator, the same thing you have to do. You also have to then what? Factorize the denominator. So you have to factorize the denominator of the function. All right. So here is going to be qx. Okay, you factorize the denominator. So if it's a linear one, like bx plus c, here you can factorize. But the only time you need to factorize is when you have maybe a cubic function or you have a quadratic function, and I showed you how to do this. So after you're done with that, step 4 is that you then have to rewrite step 1. So that means you write the standard form, what we talked about. You write step 1 using the answers from step 2 and 3. So you're using the answer from step 2 and 3. So that means you rewrite step 1 using the answer from step 2 and 3. Now, when you're done with that, the next thing then you have to do is that you then have to identify common factors that can be struck off to get a simplified fraction. So because you have factorized the numerator, you factorize the denominator, you will see if you can cancel out any common factors, all right? So that means you have to identify the common factors, all right? So the next one is that you then have to identify. So don't worry, I'm going to pick an example and solve, so you will see. So the next one is that you have to identify the common factors. So the key word here is the common what? Factors. So you have to identify common factors. All right? That can be struck off. Okay, you have to identify common factors that can be struck off to get a simpler fraction. Okay, so you have to identify common factors that can be struck off to get a simplified fraction, okay? Then when you've done that, you've identified the common factors. Then number 6, step 6, what you then have to do then is that you then have to equate the common factors from step 4, all right? So you have to equate the common factors you've got from step 4 to 0 to find x. So equate the common factors from step, the common factors we identified it is step 5. So from step 5, okay? So you equate the common factor from step 5 to 0 to find what? To find 4x. Okay? Now, after you found x, the next thing then you have to then find the corresponding value for y by substituting x in the simplified fraction from step 5, okay? So in the simplified fractions step from step 5. So you then have to then find the corresponding y values. Okay, by substituting x. So remember the x value, you've gotten the x value from step 6 in the simplified what? in the simplified fraction from step 4. Oh, sorry, step 5, okay? So we've already gotten the simplified fraction already. Then, when you've done that, you then write the whole in the coordinate form, all right? So you then write the whole coordinates, all right? So you now write the whole coordinates in the form of x comma y. All right? And that is how you find the whole of the equation. All right? So the first thing you have to do, you write it in a rational function in the standard form. You factorize the numerator, you factorize the denominator, you rewrite the standard form using the factorized format. You identify common factors to and therefore you simplify. But the common factors you've got from step 5, you equate it to 0 to find for x. Then you find the corresponding value of y, and you write down the wholes in the form. Okay, so and that is that for that. So we're going to pick an example now. All right, so let's solve this question here. So for example, okay, we're told, let's say we're told to find the wholes of the function. Okay, so we are having f of x is equal to x squared plus 5x plus 6 divided by x squared plus x minus 2. All right, so we're told to find the wholes of this function. I remember I told you in the video, I said that not all rational functions have a whole. All right, so let us see if this rational function we have here has a whole. So let's go. What's the step? So step 1 is that we have to write it in the standard form. So the first thing we can see here is that this is 2 polynomials. So we're having a ratio of 2 quadratic equations. So the P of x is a quadratic, the Q of x is also a quadratic equation. So we can write this in the form of a standard form. So we can now say the f of x is equal to the P of x, which is this polynomial here, divided by the Q of x, which is also this polynomial here. And the D here is 0. Are you seeing it? The constant here is 0. So, but because it's already 0, I can just ignore that and just go straight and solve it. Is that okay? Now let's go to step 2. Step 2 said that we need to factorize the numerator of the function. All right, so let's go back. So step 2, the numerator of the function is x squared plus 5x plus 6. We need to factorize this. So I've already talked about factorization in the previous videos. I showed you different ways of factorizing. We have difference of 2 squares, common factors, when a is equal to 1, trinomials when a is not equal to 1. And I also showed you how to use quadratic formula to factorize, okay? So I'm going to use trinomials when a is equal to 1. The method, I'm going to use this method here. So I'm going to look for 2 numbers that I'm going to multiply. That will give me 6. And when I add those 2 numbers, it's going to give me 5. And that'll be 3 and 2. So it's going to be x plus 2, x plus 3. So please, if you've forgotten how to factorize, I'll advise you to go back and have a look and check and see how do you factorize again. All right. So remember, I always say every topic we talk about when we're moving forward is built on the understanding of the previous video. So you have to follow the videos in sequentially so that you will not miss out of anything. All right, let's go to step 3. Step 3 then said we need to factorize the denominator of the function. All right, what is the denominator of the function? X squared plus x minus 2. So step 3, I'm going to do the same thing. I'm going to have x squared plus x minus 2. All right. I'm going to also use trinomials when a is equal to 1. So you can use any of the method. You can also use quadratic formula to factorize, but I also showed you a trick that the quadratic formula solves, but you can reverse it back to factorize. So I'm going to use trinomials in this case. I'm looking for 2 numbers. I'm going to multiply. That will give me minus 2 And when I add, it's going to give me +1. So it's going to be x plus 2 and x minus 1. By step 3. Good. Now the next one, we're going to go to step 4. So step 4. Okay. So step 4 now said that we have to rewrite step 1 using the answer from step 2 and 3. So we're going to write, so instead of us having, we have f of x, okay? So instead of us having x squared plus 5x plus 6, I'm going to rewrite it with what? X plus 2 and x plus 3, all right? Then also, instead of me having x squared plus x minus 2, I'm going to rewrite it as x plus 2 and x minus 1. All right, good. Now, but what did step 5 now says? Step 5 said identify the common what? Factors that can be struck off to get a simplified fraction. So let's go back. Step 5. So what are the common factors between both of them? Now, the common factors between the numerator and the denominator is what? So the common factors is x plus 2. So you're looking for the number or the factor that is both common to the numerator and the denominator is x plus 2. Now, the next thing is that when you strike it off, what will be the simplified fraction? Okay, the simplified fraction. So when you strike it off, when this is struck off, the simplified fraction you're going to have will become x plus 3 divided by x minus 1. Are you seeing it? So we're back now. So the common factors is x plus 2. Now the simplified fraction, when you strike it off, is going to be x plus 3, x minus 1. Now let's go to step 6. Now, step 6 said that you have to then equate the common factors from step 5 to be 0 to find x. So we have to equate the common factors to find x. So let's go to step 6. So what's the common factor? So it will be x plus 2 will be equal to 0. So therefore, x will be equal to what? Minus 2. So we found the value for x to be minus 2. All right. Good. Now let's go to the next one. Step 7. Now for step 7, we're told that to find the corresponding values for y by substituting x into the simplified fraction from step 5. Now we're looking for the simplified fraction, which was x plus 3 divided by x minus 1. So we know y. We have it to be y to be equal to x plus 3 divided by x minus 1, right? That was the simplified fraction. But we know the x to be minus 2. So we're going to have minus 2 plus 3 divided by minus 2 minus 1. Minus 2 plus 3 will give you minus, will give you 1, because minus 2 plus 3 will give you 1. Then minus 2 minus 3 will give you minus 3. So therefore, we can now say the y is equal to minus 1 over 3. Then step 8, write the whole coordinates in the form of x and y. So we know our x is minus 2 and our y is going to be minus 1 over 3. So that means step 8, the whole for this function, okay, is equal to x is what? Minus 2. And the y is minus 1 over what? Minus 1 over 3. Okay, and that is that for that. Okay, so that is the whole, and that means if you draw, that means if you sketch this graph of x squared plus 5x plus 6 at the point of minus 2 and minus 1 over 3, there is a hole in the graph. Okay, and that is that for that. All right, so that'll bring me to the end for this video. So please try as much as possible to review and pick different kind of rational functions and see if you can find holes in it. So remember, I told you that not all rational functions will have holes. Some will and some won't. All right. And also, I'll just go straight to the next topic now, which is vertical asymptotes. So remember, we talked about there are three types. We have the vertical, the horizontal, and the slant. Okay. So I'm going to talk about the vertical asymptotes and how do you find the vertical asymptote, and how do you now, if you want to sketch it, where you be expecting the vertical asymptote to be. All right, so I'm going to see you in the next video. So if you've not liked and subscribed and share this with your friends, I don't know what you're waiting for. And if you have some topics that you're not really sure, please put it in the comment section and I'm going to talk about it. Is that all right? So I'm going to see you in the next video.